Gravastars, the cosmic destroyers more terrifying than black holes. Welcome to the edge of the cosmos where the universe hides its darkest secrets. Today we're diving into a mind-bending mystery that could challenge everything we know about black holes. It's called a Gravastar, a cosmic object so strange it might just be more terrifying than a black hole. Buckle up, hit that like button, and let's explore the universe together. What if black holes aren't even real? There's a cosmic object scientists believe could be even more terrifying. It's called a Gravastar, and it could rewrite everything we thought we knew about the universe. What is a Gravastar? To grasp why Gravastars are so revolutionary, let's first revisit black holes. Black holes are the universe's ultimate traps, regions of space where gravity is so intense that nothing, not even light, can escape. They form when massive stars exhaust their fuel and collapse under their own weight, creating a singularity, a point of infinite density where the laws of physics as we know them break down. It's a cosmic dead end, a place where our equations fail, leaving scientists scratching their heads. But Gravastars, they're an entirely different kind of beast. Proposed in 2001 by physicists Powell Mazur and Emil Mottola, Gravastars are theoretical alternatives to black holes. Instead of collapsing into a singularity, a Gravastar forms a stable, bubble-like structure with a core of exotic dark energy surrounded by an ultra-dense shell of matter. Imagine a cosmic balloon where the dark energy inside pushes outward, perfectly counteracting the crushing force of gravity. This shell is so dense, potentially made of matter compressed to the edge of physical possibility, that it mimics a black hole's gravitational pull, but without the point of no return. Why is this such a game changer? Singularities are a massive problem for physicists. They're places where our mathematical models collapse, leaving us with unanswerable questions about what lies at the heart of a black hole. Gravastars sidestep this issue by replacing the singularity with dark energy, the mysterious force believed to drive the universe's accelerating expansion. This makes Gravastars not just a theoretical curiosity, but a potential key to understanding the cosmos. They're like swapping a cosmic void for a stable, yet utterly terrifying structure that challenges our fundamental assumptions about gravity, matter, and reality itself. Are Gravastars already out there? Here's where things get truly wild. Gravastars might already be hiding in plain sight, masquerading as black holes. When we observe objects like Sagittarius, a star, the supermassive black hole at the center of our Milky Way, we're not seeing the object itself. Instead, we're detecting its gravitational effects. Things like bending light into a glowing ring or pulling nearby stars into tight elliptical orbits. Gravastars, with their ultra-dense shells, can produce almost identical effects. Their shells create gravitational fields so powerful they warp space-time in ways that mimic black holes. In 2019, the Event Horizon Telescope gave us the first ever image of a black hole's shadow, a dark silhouette surrounded by a glowing accretion disk. But what if some of those shadows actually belong to Gravastars? Scientists are starting to question whether we've been mislabeling these cosmic titans for decades. So how do Gravastars form? Picture a massive star at the end of its life, running out of nuclear fuel and collapsing under its own gravity. Normally, this collapse creates a black hole with a singularity at its core, but under certain exotic conditions, perhaps involving quantum effects, high energy physics, or even unknown forces, the collapse stops short. The star's matter compresses into a thin, ultra-dense shell, denser than anything we've observed, yet not infinite. Inside, dark energy, the same force accelerating the universe's expansion, fills the core, pushing back against gravity to create a Gravastar. This isn't just a wild idea. Some researchers believe Gravastars could explain unusual signals detected by gravitational wave observatories like LIGO and Virgo. In 2020, studies suggested that certain merger events, where two massive objects collide and produce ripples in space-time, might involve Gravastar-like objects rather than black holes. These signals show subtle differences from black hole predictions, hinting that Gravastars could be more common than we think. There's another reason Gravastars are so exciting. They might solve one of the biggest mysteries in physics, the black hole information paradox. Black holes are thought to destroy information about anything that falls into them, which clashes with the principles of quantum mechanics that say information must be preserved. Gravastars with their stable shells could potentially preserve this information, offering a cleaner solution to a problem that's puzzled scientists since Stephen Hawking first proposed it in the 1970s. It's like finding a missing piece in a cosmic cosmic jigsaw puzzle, potentially unlocking a deeper understanding of how the universe operates. What happens near a Gravastar? Let's take a daring journey to a Gravastar. You're aboard a spaceship, hurtling toward one of these cosmic monsters. From a distance, it feels exactly like approaching a black hole. The gravitational pull is so intense it stretches time and space, making your ship's instruments go haywire. Clocks slow to a crawl, and the stars around you blur into streaks of light. But here's the twist. Unlike a black hole, there's no event horizon with a Gravastar. Instead, you approach its ultra-dense shell, a barrier of matter so extreme it defies comprehension. If you hit it, what happens? Nobody knows for sure. Some theories suggest you'd be ripped apart by tidal forces, your ship shredded by the immense gravitational gradients. Others propose you'd encounter bizarre quantum effects, like time dilation so extreme that a single second feels like centuries, or even stranger phenomena we can't yet predict. This shell isn't just a barrier, it's a frontier between our universe and something unimaginable. The dark energy inside could create conditions we can't even fathom, perhaps hinting at other dimensions, exotic states of matter, or entirely new physical laws. Approaching a Gravastar would be like stepping to the edge of reality itself, where the rules of the universe might no longer apply. It's a place where the boundaries of physics are tested and the answers could redefine our understanding of existence. Why Gravastars change everything? If Gravastars are real, they're far more than just strange cosmic objects. They could hold the key to understanding dark energy, the mysterious force that makes up 68% of the universe and drives its accelerating expansion. Discovered in the late 1990s, dark energy is one of the biggest mysteries in cosmology, and we know frustratingly little about it. By studying Gravastars, we might learn why the universe is speeding up rather than slowing down, a question that's baffled scientists for decades. Gravastars could also offer clues about the early universe, where extreme conditions just after the Big Bang might have given birth to these enigmatic structures. Imagine a time when the cosmos was a chaotic soup of energy and matter, with temperatures and pressures beyond comprehension. Gravastars might have formed in those primordial moments, leaving traces we're only now beginning to detect with our most advanced telescopes and detectors. And then there's time itself. Gravastars' unique gravitational properties could reveal new insights into how gravity and time interact, potentially challenging Einstein's theory of general relativity. Their extreme environments might amplify effects like time dilation, offering a natural laboratory for testing theories about space-time. But it doesn't stop there. Gravastars could also bridge the gap between general relativity and quantum mechanics, two frameworks that famously don't get along. The shells and cores of Gravastars, where quantum effects and extreme gravity coexist, could hold clues to a unified theory of physics, a long-standing dream for scientists. Gravastars aren't just a potential replacement for black holes. They're a chance to rewrite the cosmic rulebook, opening new doors to understanding the fundamental nature of the universe. Gravastars might be the universe's best-kept secret, hiding in the shadows of black holes. If they're real, they could change how we understand dark energy, the universe's expansion, and even time itself. The cosmos is full of mysteries waiting to be uncovered, and we're just getting started. If you love this deep dive, smash that like button, hit subscribe, and ring the bell to join us on this cosmic journey. What's the next secret the universe is hiding? Let's find out together.